In this next set of videos, we're going to talk about the graphs of the sine and cosine functions. So what I have so far in our notes are some key points that either we've done together or that you could find if you extend the rules that we've already used with reference angles and things like that. So hopefully a lot of these values look very familiar to you already. And this is a good table to kind of keep with you also. So if you find it helpful, again, to have those common sine values, you can kind of keep this on a little note card and use that as well. So what I have here are some key points, and I've gone from 0 to 2 pi for my x's. One thing I want to note when we're graphing on the xy plane, so we're kind of expanding this idea from just the unit circle going around and around in a circle. We're going to actually graph it on that xy plane now. X will be our angle. So x is the angle in radians when we graph on the xy plane. And then your y value would be the sine function at that angle. And what happens is you kind of get this wave or this curve going back and forth. And remember that our values repeat over the value of 2 pi, right? The circle has 2 pi degrees. So we can keep going around as many times as we want, but those values are all the same. So I only have from 0 to 2 pi here, because after that, they would just keep repeating over and over again. And that's called having a period or being periodic. So you have that same values repeating over and over again. I did a quick drawing here. It's not great. I'm going to show you Desmos in a second, but you can kind of get the idea of what happens. So your initial kind of starting point for one period here is at 0, 0. And then what happens is as you progress through the angles, you end up going up to a high value of 1. And that occurs at pi over 2. So that was our 90 degrees. And then what happens is it goes back down, and then you hit a sine value of 0 at pi, and we continue to go down till we got to -1. And remember that happened at 3 pi over 2, which was -270 degrees on that unit circle. And then we started to come back up a little bit, and then again we wound up at 0 at 2 pi. And then what happens is this wave would just keep repeating over and over and over again, infinitely many times in both directions. So this is periodic here, meaning that it repeats. And in this case, your period is 2 pi. Meaning that it those kind of 0 to 2 pi values are unique in a way, and then those just keep repeating over and over again. So it repeats every 2 pi on the x-axis. So this is what your general sine function looks like. Let me show you Desmos. I think that'll be a little bit clearer for you. Okay, so there is our sine function again. And your computer Desmos does know that it is in radians. So again, I don't think I've ever seen the sine function graphed in degrees on an xy plane. It's done in radians. So you do want to make sure that you're noting that, but Desmos will work accordingly. So here you can see that, you can still touch some points. So there's that point 0, 0. Here's that peak. And again, Desmos is one of my favorite calculator apps. One, it's free, but it's just really easy to use, and they make the points really easy. So you can see it matches with what I had on the paper. Here's your next key point at pi 0. And then you hit that minimum value here at -1, which is at 3 pi over 2. And then again, you're back to that 0 value. And you can see it's going to repeat over and over and over again. And it goes in both directions. So I can, keep scaling this over. And you can see, there's one iteration, right, from 0, 0 to 2 pi 0. And then it's repeating again. Here's your next iteration from 2 pi over to 4 pi. So you have that 2 pi for your period. So it's going to keep repeating every 2 pi values. And it's going to continue indefinitely. You can see your max value there is 1. Your minimum is -1. And usually we call these usually we try to focus on one period at a time when graphing our sine, cosine, trig functions, because they are periodic. So if I know what happens for one group, then I can just repeat those values over and over again. So your main values for the sine function are usually the first period. So we go from 0, 0 here to 2 pi. Those are the ones we tend to focus on, because then we know we can just repeat them. And although I gave you lots of points on the handout, the 5 kind of main points would be your 3 x-intercepts, right? So where you cross that x-axis. and then your high point and your low point. If you can find those 5 points in general, and you know that the shape is, kind of like a wave curve, then you can draw the graph very easily. And we're going to use this technique as we go through different examples of the sine curve. Really kind of using those 5 key points where you cross the axis, and then also the high and the low point within the period. And then we're able to replicate that curve. Now, maybe saying, well, wait, isn't there just one sine function? And it's like, well, yes, there is, but we can always tweak things, right? Like when I have lines, there's different lines. Sometimes they go up, sometimes they go down, different slopes and things like that. And I'll just show you here a little bit. So like I could play around with this and maybe do 3 times the sine function. And you can see you have that same wave idea going on, but it's stretched. Or I could do something like y equals sine of 2x and put that 2x in parentheses. And what happens now is it's in green here and it's sort of compressed in. So it's oscillating faster. So you have those same general shapes, but we're tweaking it a little bit. And maybe I'll just do one more. What if I did y equals 1/2 sine x plus 3? So here, again, you have that same wave function here, but I've sort of compressed it vertically. That's what that 1/2 is doing, and that plus 3 is raising it up 3 units. So one way you can deal with these changes is if you remember your transformations. We don't teach transformations in this class. It is taught in a previous level class. But if you remember your transformations, then this probably all makes sense. When you multiply on the outside here, that affects the y value. So that's why for this first example, you're multiplying those y values by 3. So that's why it's getting pulled higher, up to 3 instead of up to 1. In this case here, because we're multiplying it by 1/2, let me get rid of that plus 3 for a second. You can see that the heights instead are going to only 1/2 instead of 1. And then that plus 3 is a vertical shift. It shifts it, the whole graph up 3 units. Something like this, when you have this inside multiplier, it ends up working horizontally. It either compresses it or sometimes it can make it wider. So here we're sort of compressing it and we're making that period smaller. We're oscillating faster. And of course, there's other changes you can do too. You could also shift this over left or right as well. So we're going to talk about all these changes a little bit more individually, but you can always remember as well that if you remember your transformations, then that all still applies here, even though I'm going to show you some new strategies for graphing as well. So I'm going to go back to my other screen and we're going to do some graphing by hand using these key points, but I do want to encourage you to use your technology. So I really recommend, you should know how to graph by hand, obviously, and know what each part of the function represents. So we're going to do some key vocab terms as well. But go to Desmos when you're done and plug it in and check it. Make sure you've done everything right. Make sure it makes sense. And this is just a really helpful tool here. So I'm going to just start and do kind of small changes at a time. I won't do all the changes at once. So the first one I'm going to do is talk about having a multiplier outside the sine function. So when y equals a sine x, we call the absolute value of a the amplitude. And what happens is this really tells us how tall our graph is going to be. So instead of the height just being at 1 as the max, if we have a multiplier out front, it's going to change that max height. So the maximum value of y on the graph of y equals a sine x is the absolute value of a. again, which is the amplitude. Now, I am assuming here that this is the only change. So if you start also applying a vertical shift like we saw in Desmos, doing that +3, moving the whole thing up, obviously that's going to change things too. So here we're not doing any plus or minus, we're not just shifting the whole graph up, we're just doing a multiplier right now. And that is called your amplitude. I think I'll go to a new page for our example. Okay, so the example we're gonna look at is this one. Determine the amplitude of y equals 1/2 sine x, and then we'll graph both regular sine x and 1/2 sine x on the xy plane, just from 0 to 2 pi. So again, remember that that graph will keep going on forever. A lot of times you'll see that they'll just ask you to graph just that one period, just so we can see the main part of the graph. But do know that it would extend further, of course, if you needed to. So I'm going to show you a couple techniques on how to graph by hand, and we're going to use the points we already know, but we're going to kind of tweak our process because we're tweaking the graph, right? So things are going to change a little bit because it's not just sine, it's now 1/2 sine. So the first thing I'm going to do is I'm going to find the amplitude. And it's whatever this value is out front, but it's the absolute value of it. Now here, the absolute value stays positive. Remember, the absolute value is a distance, so it's always a positive value. But if it was negative, it would make this positive as well. So the amplitude is 1/2. So what's going to happen is the max value of the graph is going to be 1/2 for the y's, and actually the min is -1/2, because it does have some symmetry to it. So if your max was 1, your min was -1. Here, if your max is 1/2, your min is going to be -1/2. Now, something like this, we're not actually changing the period. We're just affecting the height of the y values. So we're doing what's called like a vertical stretch here. So you're going to see a very similar graph. The only thing that's going to change is the height of the y's. But I do want to show you some key ideas on how to graph, because they are going to get more complicated than just a single change. So what we often like to do is to identify those 5 key points. So it's the 3 x-intercepts I showed you, the highest point, so your max, and then the lowest point, so your min, within that one period. So if I can find those 5 points, I know the general shape of the curve, I can just graph from there. So how you're going to do that, there's different ways that you can do it, but one way is to kind of follow this technique. So you're going to take the period and you're going to divide it by 4. Now our period for the sine function, and again, this may change, it gets more complicated. I'll show you what it looks like when it does change. It's just 2 pi. So we do 2 pi over 4, simplify that, becomes 1/2, so just pi over 2. And we're going to use this to create our 5 main points. So it's nice because I don't have to worry about it every single time where they occur. I can just use this strategy here. So your first point is where the cycle begins. And in general, for the sine function, that begins at 0. So your first value will be x is 0. Again, this may change, and I'll show you what that looks like. We're not there yet. So I'm just kind of doing a basic example first, where we just have a little tiny change. It doesn't affect too much. It just affects the height of the sine function. And then what you're going to do is you're going to add whatever this is. So here we're going to add pi over 2 to x. So our second point would be that 0 plus pi over 2, which is obviously just pi over 2. We're going to do it again. So our third point, again, would be pi over 2 plus pi over 2 here. So you'd have just pi. Again, we're going to add that pi over 2. So this is what gets added. All right, so this becomes actually 2 pi over 2, just use common denominator. So I end up with 3 pi over 2. And then for the fifth one, and I'm just using little subscripts here just to show points 1 through 5. They don't really mean anything. You can just write x if you want to. 3 pi over 2 plus pi over 2 is 4 pi over 2 or 2 pi. So these are the x values where those main points are going to occur, those 5 key points, your intercepts, your highest point, and your lowest point. So let's go ahead and actually find the y values, and then we're ready to graph. So what you can do here, I guess I could have made a larger table, but I'll just do it down here. I'm gonna make my x's and my y's. And again, I'm just gonna use those 5 key points. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. And my y here is 1/2 sine x. So now what I'll do is I'll just plug in the x values into my equation. I have my key points here. I know where those key x values are, and I'll get the y values. So I have 1/2 times the sine of 0. Sine of 0 is still 0, so I have 1/2 times 0 is 0. 1/2 times sine of pi over 2 for the next one. So 1/2 sine of pi over 2 is 1, so this becomes just 1/2. Now sine of pi again is 0, so 1/2 times 0 is 0. Sine of 3 pi over 2 is -1, so this is -1/2. And then finally, sine of 2 pi is 0 again. So I have 0. So there are my 5 key points. And I'm just going to try to kind of graph it right here. All right, so I'm going to have 0. I'm going to have pi over 2, pi, 3 pi over 2, and 2 pi. So those are my key points here. And again, I only have to graph it from 0 to 2 pi for the instructions. So obviously this extends, but I'm just going to focus on this part here. My highest value is 1/2. So I'm going to let, we'll call this 1/2 and this be 1, just kind of trying to get a rough scale here. -1/2 and then -1. So for this graph here, I'm going to go ahead and do that in blue. We have 0, 0. At pi over 2, I'm at 1/2. At pi, I'm at 0. At 3 pi over 2, I'm at -1/2. Just about right there. And then at 0 again. And again, we know the general shape, so we can just go ahead and connect those. Now, I also wanted us to graph the original sine function. So you can go back to your chart on the first page. 0, 0 was there. At pi over 2, we were at 1. At pi, we were at 0. At 3 pi over 2, we're at -1, and then we're back here. So your original, and again, I'm just kind of doing a rough drawing here, looks like this. So when you only have a change in amplitude, a multiplier on the outside, it's actually pretty quick to graph. If you know your original graph very well, you're going to notice that the first point, the middle point, and the third point all stay at 0, and it's only the maximum heights that are really changing. So this is kind of nice. If you just, again, if you just have that one change to amplitude, it's very quick to graph. You can kind of skip some of these steps because you're not changing the period. The only thing you're changing are that max and min height. I will show you some examples where it gets more complicated though. So we do have to be a little bit more careful there as well. All right, so let's do another one. All right, so similar thing, I'm just changing the amplitude. Nothing else is changing. I only have a multiplier out front. So you're not going to see too much change. You're going to see changes in the max and mins though. The negative here will also end up giving you what's called a reflection or a flip. So you actually will see that the graph almost flips vertically. And we'll see that when we're graphing too. But we start the same way. So the amplitude is the absolute value of A. So our A here is -2. So it is +2. So your amplitude is positive. So the amplitude is 2. So what's going to happen here is your max Y value is 2. And your minimum Y value is -2. So that idea doesn't change. And again, we're only changing the amplitude. If I had vertical shifts and stuff, then that would also affect the graph. But here we're just doing that one amplitude change. Now I want to find my 5 key points. And remember, to do that, you're going to take that period and divide it by 4. Now my period of the sine function is 2 pi. That can change if we do enough modifying, but I'll show you what that looks like. We haven't seen that yet. So this is pi over 2, and you're going to see we actually have the same 5 key x values. So I'm going to save us a little bit of work. You can look at the work from the last example. Our starting value was 0, and then we had pi over 2, pi, 3 pi over 2, and 2 pi. And again, that doesn't change because we haven't affected the period at all. It's the same period as it has been. So now I'm going to go ahead and plug in those values. Sine of 0 is 0, so this first part just stays 0. You don't really need parentheses around the 0 or pi over 2. Sometimes I just like it. It just helps me read it a little bit clearer. Sine of pi over 2 is 1, so this becomes -2. Sine of pi again is 0. Now, sine of 3 pi over 2 is actually -1, so this flips it back to positive when I multiply those two negatives. And again, sine of 2 pi is also 0. So again, the only thing that's changing are those max and min values. So when I graph, I'm just going to graph these 5 points. And again, know that it does continue on. So I have 0, I have pi over 2, pi. I'm just doing my best to kind of equally space these because they are equidistant apart, right? We added the same value each time. Here I'm going up, we'll say this is 1, we'll call this 2, -1, -2, and I'll do it in blue again. So my first point is 0, 0. And then at pi over 2, I'm at -2. At pi, I'm at 0. At 3 pi over 2, I'm at +2. And then I'm back to 0. And again, I'm just graphing it from 0 to 2 pi, but you know, this does keep going. You know, my graph's kind of lousy here, but it does keep going. It's going to keep seeing that same pattern. The original sine function, just so you remember, it was 0, 0. And then it was at 1, 0, 0, -1, back to 0. So again, that pink one is your original sine function. So you can see that by multiplying by that 2, we had that vertical stretch. We're pulling them up higher. But what happens is that negative out front caused that flip. So instead of it being our max here, it went to the min. And instead of it being the min, it went to the max. So a negative out front will cause that flipping action. And again, if you remember your transformations from a previous algebra class, then we would know that already. But if you haven't seen it in a while, know that the negative out front will cause that flipping. So it's always good habit just to kind of check your y values, particularly if you haven't done your transformations in a while. But if you remember those, it'll just make the process much quicker for you or just easier to understand as well. Okay, I'm going to do some harder changes. So I think what I'll do is I'll stop this video so it doesn't get too long. You can kind of process this and come back to the next video and you'll see still working with the sine function, but some more complicated changes.